So we're going to start by just recapping what we did last week on Thursday. So we started with two types of rational functions. There's the reciprocal function that just has a number at the top of the fraction. And then there's a standard rational function that has a polynomial sitting up there. So the main things that we worked on Thursday, one, identifying zeros. Zeros are x-intercepts. Set the function equal to 0 and solve it. Set the function equal to 0 and solve it. The shorthand way of doing it is taking your numerator and solving it. So either way works. Vertical asymptotes. Set the denominator equal to 0 and then solve it out. Horizontal asymptotes. If it's a reciprocal function, in other words, if there's a number behind the fraction, then that's your horizontal asymptote. If there is no number behind the fraction, then you look at the degree of the top and the bottom of the fraction. If the top is bigger, there's no horizontal asymptote. If the bottom is bigger, then the horizontal asymptote is y equals 0. If they're equal, then you divide them out. Then you divide out the first terms. That's how you get your horizontal asymptote. And then lastly, points of discontinuity, which was one of the extra credit questions from your quiz. Take the function, simplify it. Whatever part that cancels out, you set that part equal to 0, and then plug it into whatever's left over. That will tell you what your whole is. That will tell you the whole of the function. Obviously, if nothing cancels out, then you don't have any holes. So that's a quick overview of what we did on Thursday. Now we're going to get into actually doing the work. Any questions before we continue? And all right, let's go ahead. Do some graphing. So, in order to graph, we're going to do the exact same things that we did on Thursday. So, this is the second page for you. So, we're going to do the exact same things that we did on Thursday. So, the first thing are zeros. So, for the zeros, take your function, set it equal to 0. Take the function, set it equal to 0. So that gives us 6 over x minus 2 equals negative 3. Of course, we're going to make that negative 3 a fraction so that we can cross multiply. So 6 times 1 is 6. 3 times, negative 3 times x minus 2. That's negative 3x plus 6. And there's interference in the board, so I apologize for that. Subtract 6 on both sides. And then divide by negative 3. So your 0 is at x equals 0. So since you have a 0 there, zeros are x-intercepts. So that means on your graph, go to your graph, put a point at 0. So your graph for the point of 0. Any questions before we continue? Good, Mike? All right, so vertical asymptote. Vertical asymptote, take the denominator, set it equal to 0. That's pretty simple. X equals 2. That's your vertical asymptote. So this is how we draw a vertical asymptote. Go to the x-axis, find x equals 2, and draw a vertical line through it. Now, notice I am drawing a dotted line. I don't care what kind of line you use. Just make sure that there's a line going up and down, x equals 2. You want to draw a solid line? Be my guest. Just make sure that there's a line there. That means your graph can't touch that line. It cannot touch that line. Horizontal asymptote. So that's y equals k if you have a number sitting behind a fraction. Remember, if you have a number sitting behind a fraction, that's your horizontal asymptote. So if number behind fraction. So that's y equals 30. So this is how you do, and this is how you draw it. Go to the y-axis and put a line, horizontal line, through y equals 3. Again, I don't care if it's solid or dotted, just make sure it's there. Then the last thing to check for before we use the calculator are holes. Now we're going to check for holes in the graph. So we would take 6 over x minus 2 and simplify it. However, you can't. So can't simplify it. So there's no holes. There'll be no holes in this graph. There's no holes in this graph. Simplifying it means you can factor the top, you can factor the bottom, and something will drop out. That's what it means to be able to simplify. So, anyone with any questions before we turn to our calculator? So you only look at the fraction when looking for holes. Absolutely right. So Jola asks, you only look at the fraction when you're looking for holes? Absolutely. The fraction is the only thing that would give you a hole in the graph. Fraction is the only thing that will give you a hole in the graph. So excellent question there. Let's go ahead and use the calculator. So, pull up our calculator. Again, if you don't have a graphing calculator, I'll gladly provide a link that you can put one on the Chromebook. Otherwise, you can use Desmos to get a sketch of what the calculator looks like, or what the graph will look like, but you are responsible for drawing the graph. So, y equals, type in the numerator, which was 6, divided by, now, the denominator, put it in parentheses. The denominator, put it in parentheses. So parentheses, x minus 2. Make sure I got that right. And then type in plus 3. Always put the denominator in parentheses. Always put the denominator in parentheses. Anyone got any questions before we continue? Okay, the main thing with the calculator, always put it in parentheses. Now we're going to take a sneak peek at the graph. We want to see what should this graph look like. So to take a sneak peek, let's press graph. Now, most graphing calculators do not graph asymptotes. They do not show asymptotes. But one of your asymptotes was x equals 2, it would have been right there. Notice that the graph doesn't touch it. Your horizontal asymptote was y equals 3. Notice it doesn't touch it. So the graph doesn't touch either one. So when you draw your graph, they're going to flirt with the line. They are not going to touch the line. They're going to flirt with it, they're not going to touch it. So as far as the points that we plot, we let the table give us those. The table's going to do the work for us. So hit second, hit graph. So, in terms of how many points you pick, 3 on each side. So, 2, that's your vertical asymptote. So, 3 points on each side. Which ones you pick whatever you want. Now, if it's me, I'm going to pick points that are easy for me to plot. I'm going to pick points that are easy to plot. So I'm going to pick those 3, and I'm going to pick those 3. So remember, 3 on each side. You're picking 3 on each side. So when you draw your graphs, I'm going to check for the points. But if you just draw some squiggly line thinking that's going to pass, no, it's not. It's called being lazy. Don't be lazy. You done made it this far. Don't be lazy. Three times 9. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 5, 1, 2, 3, 4, 5. That's it. There's your graph. All right, any questions on our first graph? Any questions on the first graph? So again, the main things I would check for are your vertical asymptote, your horizontal asymptote, holes in the graph if there are any, and then your actual curves. So each curve should have 3 points. So 3 points per curve. Each curve should have 3 points. So if the points are whole numbers, then I expect you to plot whole numbers good. If they're decimals, then I expect you to just estimate. If they're decimals, which decimals are going to happen, I just expect you to estimate. I don't expect it to be dead on perfect. So, example 13. So example 13, we're not going to do anything. Well, we're not going to do most of it that much different. So let's start with the zeros. So zeros, take the function, set it equal to 0. So when you cross multiply, 2x times 1 is 2x. 0 times x squared minus 3x minus 10, 0. Anything times 0, 0. So you get x equals 0. So remember, the shortcut is taking the numerator and setting it equal to 0. That's the shortcut. So x equals 0 is your x-intercept. So the graph, the point there. Vertical asymptote. Take your denominator, set it equal to 0. So our denominator is equal to 0. Our denominator has x squared. We're going to have to factor it. X minus 5, x plus 2. So x equals 5, and x equals negative 2. Mr. Lowe, I got 2 vertical asymptotes. So, we have 2 vertical asymptotes. That means you're going to have 2 vertical lines. One going down negative 2. And one going down 5. You're just going to have 2 of them. Any questions so far? You can either come off mute or type them in the chat. Either one works. Go over here. All right, so we got our vertical asymptotes. So, horizontal asymptotes. Since you do not have a number sitting behind, now you have to look at the degrees. So you look at the degrees when you don't have a number behind it. So the top degree, so remember, degree is biggest exponent. Top degree is 1. The bottom degree is 2. 1 is less than 2, so the top is less than the bottom. So your horizontal asymptote is y equals 0. Y equals 0. What? What? So if your bottom degree is bigger, that means the bottom of the function is forever going to get bigger and bigger and bigger. So if I put any number in there for x, it's always going to be bigger than the numerator. So if the number in the bottom of the fraction keeps getting bigger and bigger and bigger, it's eventually just going to be 0. So for example, if you take 2 and divide by 1,000,000,000, what's going to happen? You're going to get some very, 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 very small number. If you have a very, 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 very small number, that means you're getting closer to the number 0. That's where the 0 comes from. So that's why the horizontal asymptote ends up being 0. So, good question. That's definitely something you're going to need to know for those of you who are going off the pre-calc next year. So since y equals 0 is your horizontal, go to the y-axis. And put your horizontal line through 0. So that means part of this function is going to flirt with that line, but it's not going to touch that line. Part of this curve should flirt with it, but not touch it. So the last part before we go to our calculator are the holes. Just like Sheldon said, you only look at the fraction for the holes. So we take this fraction and we simplify it. So the top is not going to simplify anymore. The bottom, we should know what that is. We factored it already. So you tell me, does anything cancel out? Anything look like they're going to cancel out? The short answer to this is no. None of that's canceling out. Now, some of you all might have been thinking just a little bit. You can cancel out that 2. No, you can't. That 2 is connected to the x. We can cancel out that x. No, you can't. This x is connected to a -5, and that x is connected to a 2. They have to match up exactly in order to drop out. So there are no holes. There are no holes in this graph. Any questions before we let the calculator do some work? All right. Let's let the calculator do a little work there. These. Go to y equals, clear out what you had. Then the top of the fraction, type in first, divided by, open the parentheses, x squared minus 3x minus 10. So, you always want to get a sneak peek of that graph, just so that you know how it should look. So just press graph, that way you can get a sneak peek. So if we get our sneak peek, remember we had a asymptote at -2. We had an asymptote at 5. And notice that 0 was the horizontal asymptote. This part of the graph and this part of the graph are flirting with that line. They're not touching it, they're flirting. So we now know what our graph should look like. So those of you with a graphing calculator, it's like a cheat code. You got a cheat code. Use it. So let's go to the table and pull some points. So, remember the first example we had to pull 3 points per side. So your vertical asymptote was -2 and 5. Those are your vertical asymptotes. So that means you're going to pick 3 points in each part. So 3 points each side. 3 points in the middle. And 3 points to the right-hand side of the graph. So you're going to have a left, middle, and a right. You're going to have a left, middle, and a right. So, as I told you before we started this problem, you're going to have decimals sometimes. Decimals, you do the best that you can. Those are estimates. I'm not going to overly penalize you on plotting decimals. I'm not going to overly penalize you for plotting decimals. So in this case, you may have to move your calculator up or down just so that you can see the numbers. So I'm going to plot, because I kind of did this already, -5 and -0.3, -4, 0.4, -3, and 0.75. So those will be my 3 points on the left. My points in the middle, -1.3, 0, 0, and 1 comma, -0.2. And then my other points will be 6 comma, 1.5, 7 comma, 0.8, and 8 comma, 0.5. So if you're wondering where am I getting all the numbers from, I'm pulling them from the table. I'm pulling them from the table from my graphing calculator. So let's go ahead and graph it. -5 comma, -0.3, -4 comma, -0.4, 3, comma, negative 0.75. Again, they are decimals. I'm not going to penalize you if they are not 100% exact. So you're not going to get penalized for that. Now, you will get penalized if you put something that wasn't even on the table. So if it wasn't even on the table, then that's a problem. So now you see why I told you to look at the graph first. Look at the graph first so that you can get a sneak peek. Look at the graph first so you can get a sneak peek. So chances are the ones that you will be doing for your unit test next week or for a final will be something that's relatively easy to grab. But just know with decimals, I'm not going to overly penalize with decimals. Any questions on graph number 2? How are we looking over there, Mike? This is a lot easier to do with someone in the classroom, and I'm not doing it to a whole bunch of blank desks. I'm still doing it to a whole bunch of blank desks, but it's actually nice to have someone. It feels more normal. Then I bet you're definitely tired of being at home. Yeah. All right, last example. The last example, x squared plus x minus 2, x squared minus 5x minus 14. So the same rules essentially apply. Start with your zeros. So now that we know the shortcut, let's use the shortcut. Take the numerator, set it equal to 0. Take the numerator, set it equal to 0. That's x plus 2 and x minus 1. So x equals negative 2 and x equals 1. Those are your two zeros. So one of your points goes at negative 2, one of your points goes at 1. So I'm putting a star behind next to the x equals negative 2. There's something very, very special about that one, which you'll see right now. Vertical asymptote. Take the denominator and set it equal to 0. So again, this is MAF factoring. X minus 7, x plus 2. So x equals 7, x equals negative 2. What do you notice with negative 2? Same as a 0. You have a 0 and you have a vertical asymptote. So if you have a 0 and a vertical asymptote as the same number, you have a hole. You have a hole in the graph. That is a hole in the graph. So -2, 0 is a hole in the graph. So change that solid dot to an open circle. Now you have a hole in the graph. Any questions before we continue? So this only happens if a 0 and a vertical asymptote are the same number. So I'm highlighting it for those people who might go back and look at this later. If a 0 and a vertical asymptote is the same number, you have a hole in the graph. So let's keep moving. Horizontal asymptote, there's nothing behind the fraction, so we look at the degree. So the top degree is equal to 2. Remember, the degree is the biggest exponent. Bottom degree is 2. So 2 equals 2. They're equal to each other. So that means to get the horizontal asymptote, we divide. X squared divided by x squared is 1. So y equals 1. And let's see. So we got 0, we got vertical asymptote, we got horizontal asymptote. Need a minute, Mike, or you good?
Oh, I was running.
Okay. Anybody need a second? Now let's take care of the holes in the graph. Holes in the graph means take the function and simplify it. So take your function and simplify it. So it gives you x squared plus x minus 2. We already factored that out earlier. X squared minus 5x minus 14. We already factored that earlier. So x plus 2 cancels out. And you're left with x minus 1 over x minus 7. So take whatever canceled out. 7 equal to 0. And then take the number and plug it in. -3 over -9 is 1/3. So that's another hole for that graph. Will we have to graph it? Probably not. Because because you already have a hole at x equals -2. So that hole probably won't get graphed. But at least we know that it exists. Any questions before we start setting up this graph? Notice this time I did all the work before we actually touched the graph. The order that you do it in is basically whichever way you're most comfortable with. If you want to go back and forth, back and forth, back and forth, that's okay. If that's what you're comfortable with, do it that way. So now let's graph. The zeros we already put on the graph. The vertical asymptotes was -2 and 7. So -2 already has a hole on it. So we wouldn't put a vertical asymptote where a hole is. The hole is there, we leave it alone. Go to 7. 1, 2, 3, 4, 5, 6, 7. Draw your vertical line. Your horizontal asymptote is 1. And the holes we took care of. So now we just need to do the graph. So let's take care of that. Now, for this type of function, if you have a function, if you have a polynomial at the top and a polar polynomial at the bottom, put both parts in parentheses. You want this way the calculator knows what you're talking about. You're trying to make sure the calculator doesn't screw anything up. So this time, put both parts in parentheses. This is just to make sure that the calculator doesn't mess anything up. You want to make sure the calculator doesn't mess anything up. Now, if you don't want to listen to me and you want to not put parentheses in the top part, then be my guest. Just take the advice of someone who's been teaching this for 15 years and knows what could happen if you don't. Yes, sir. So, let's take a sneak peek. So our 1, 2, 3, 4, 5, 6, 7 vertical asymptote right there. Horizontal asymptote right there. Which means all we need to do now is pick the points, plot the points, and we're good to go. Go to our table. So remember, it's 3 points on each side. 3 points on each side of the vertical asymptote. And then, so as you look at it, these points are actually pretty easy to get. So there's 3 points that I could use, and there's 3 points that I could use. So these are pretty simple to get. So in that case, that's what I'll plot before I post this to the classroom. Any questions with example 3 before we call it a Tuesday? All right, you good over there?
Yeah.